Hello everyone, welcome back to our channel. Today we're diving into a topic that powers our world, means electricity. Whether you're studying for your GCSEs or just curious about how electricity works, you're in the right place. So let's spark up some knowledge on a brief video about the fundamentals of mains electricity so you can get an idea of what the concept is. So before we jump into mains electricity, let's quickly recap some basics of what comes into the topic of electricity. We have a lot of talk about current being the electric flow of charge. And this flow is typically driven by the movement of a charge carrier like electrons in a conductor like a copper wire. And what we're referring to here is we're referring to, this working together to power our homes, power our businesses, power the society around us. So mains electricity, which is an alternating current, or AC, which means the direction of the current changes periodically. In most countries, including the United Kingdom, operates at around 230 volts. Let's kind of talk about what volts mean as a little recap before we get into more about mains electricity. So you can imagine a water pipe or a reservoir like we have here, right? Voltage is like the pressure of the water flowing through the pipe. So in the case of higher voltage, the more push is given to the charge carriers, which are very likely the electrons, and we're going to get higher current. But just like with the water, too much pressure can be dangerous. That's why we need to be careful when we're dealing with mains electricity. So, speaking of safety, it's crucial to handle these voltages and currents with care. So, never should we be touching bare wires connected to a circuit, and always switch off the power before we're operating on electrical circuits, because safety isn't just about protecting yourself. It's also about preventing electrical fires and other hazards in the wider system it's connected to. Now let's talk about the components of mains electricity. Just an overview here. We'll do, future videos that delve into all of these specific things because they're all topics within themselves to understand and equations to appreciate. But let's have a look at what we've got here. So we start off on the far left of the screen with the power station. Maybe that is natural gas, maybe that's nuclear, who knows? But we have our power station there, which is, at the end of it, operating with a turbine of a magnetic field cutting through a coil of wire perpendicular to each other, and we get an induced potential difference. We get induced voltage. We have generated electricity, if you will. Then we have that current traveling through towards a transformer. See, here we have a step up, transformer, some transmission cables, and then a step down transformer. Now, the rules of these transformer substations, the purpose of them, rather I should say, is to increase or decrease the voltage for the needs of the situation. So we're increasing it or decreasing it to either to satisfy the needs of the electrical appliance it's connected to, or we're increasing it or decreasing it to satisfy transmission needs or reduction of hazards and things like that. All right. So the current travels through the transformers, which, as we're saying, is needed to increase or decrease the voltage as required. We have it flowing through these transmission cables, through various substations where the voltage is further adjusted for distribution to the consumer, right? The homes and the businesses. And inside our homes, inside our buildings, the current flows through the circuits that connect everything, right? And a circuit for your home or your office building or your school or whatever typically includes a fuse box, a circuit breaker, a consumer unit, and wiring that connects to the various outlets we have on the walls and the appliances. Now, the fuses and the circuit breaker specifically, I've got a image here of a circuit breaker, is to protect against overloads. The name is really, really descriptive of the function of the circuit breaker. It breaks the circuit. It shuts down. It shuts down the circuit if too much current is flowing through it, so we can prevent those things like we can keep human safety, as it should be. We can be reducing the risk of electrical fires. We can be reducing the risk to appliances and things that are connected to the circuit. And now when we plug in devices like lamps or chargers or whatever into our main supply and wherever we happen to be, the electrostatic source, the electrostatic store of energy, is transformed into other forms of energy as dictated by the appliance, right? So, for example, the light bulb is going to be operating, transferring that electrostatic store into light and heat. Light, of course, being the useful transfer that's happening there, the useful pathway. Understanding how energy transforms, how it transfers, it's not being created or destroyed, how it's transferring to be mass, or it's transferring to be waves, or it's radiation, or other forms of energy, is really essential for many aspects of science and technology. And we can see it's forming a part in what we're talking about here as well. And there we have it for today. Really just a brief look and overview, and all these different concepts of like electrical generation, different types of AC, DC circuit systems. I will dive into these in a lot more videos that may or may not be posted by this time when you found this. But just a little crash course in mains electricity. Now, whether you're studying for exams or you just want to know more about how the world works, for me, electricity is a fascinating topic with a lot of scope to it. But always, as Uncle Ben said, great power comes great responsibility. So stay safe when dealing with electrical circuits and things like that if you are a tinkerer or a young engineer yourself. But thanks for watching. Don't forget to like, comment, and subscribe for more educational content. I'm just going to be talking about my links now. So if you want to go away, that is fine. But if you want to hang around and listen to me talk about other places you can find me, feel free. So once again, thank you. Interest and support, as usual, mean a lot. I am here to try and spread education and awareness of fundamental scientific concepts. If you need any help, if there's anything I said unclearly, or you've got suggestions, or you've got requests, you just comment those and I will help you out. Here's my links to everything as usual. We've got the link tree. You're already here on the YouTube. I've got the TED storefront there for free and paid content. I've got the Twitter page, the Instagram, and if you would like to buy me a coffee, that would be great because that helps me pay for running shoes, which I have to frequently replace every few months. So thank you again, and I'll see you all in the next one. Bye, bye, bye.